Welcome to the journey of a lifetime. Today we're unraveling the mystery of making air on Mars. Yes, you heard it right. We're diving into the captivating process of generating oxygen on the red planet, setting the stage for future human exploration. So buckle up as we embark on an interplanetary adventure. Before we dive into the how, we must understand the why. Why do we need to create oxygen on Mars? Oxygen, as we know, is a key component for human survival. It's not just about breathing, but also about providing energy to our cells, helping in digestion, and even aiding in the healing process. Now imagine an environment where this life-sustaining element is scarce. Welcome to Mars. The red planet's atmosphere is primarily composed of carbon dioxide with traces of nitrogen and argon, but only a minuscule amount of oxygen. So, for humans to live there, we need to figure out a way to generate this vital resource. However, transporting oxygen from Earth to Mars is quite a challenge. Picture this. It's like moving a mountain one pebble at a time. The distance between Earth and Mars varies, but at its closest, it's still a whopping 33 million miles. It's not only about the distance, but also about the weight. Oxygen is heavy, and the more weight we need to launch into space, the more fuel we require, escalating the costs exponentially. Then there's the issue of self-sustainability. For any long-term mission on Mars, reliance on Earth for supplies is not feasible. We need a way to produce oxygen on Mars to ensure that future explorers are self-sufficient. Thus, creating oxygen on Mars becomes a matter of life and survival. Now, to make oxygen, we need to understand what we are working with. So, what does Mars's atmosphere consist of? Mars, also known as the red planet, has an atmosphere that's quite different from what we're used to here on Earth. It's incredibly thin. Only about 1% as dense as Earth's atmosphere at sea level. Now, this thin atmosphere is mostly made up of carbon dioxide, a whopping 95% to be exact. The rest is a mix of nitrogen and argon, with trace amounts of oxygen and water. The high carbon dioxide content is what really piques our interest. You see, carbon dioxide, or CO2, is a molecule made up of one carbon atom and two oxygen atoms. So if we could find a way to break apart that CO2, we'd have a source of oxygen right there on Mars. And that's exactly what scientists have been working on. They've developed technologies like MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment, which is currently aboard the Perseverance rover on Mars. MOXIE works by sucking in the Martian atmosphere, heating it up, and using an electrochemical process to separate the oxygen atoms from the carbon dioxide. The result is pure, breathable oxygen. Now, one might ask, why all the fuss about making oxygen on Mars when we could just bring it from Earth? Well, oxygen is heavy and takes up a lot of space. Transporting enough oxygen for a Mars mission would be incredibly expensive and impractical. So creating oxygen on Mars not only solves the problem of providing breathable air for astronauts, but it could also be used to create rocket fuel for the return journey to Earth. So, the key to our oxygen lies in the red planet's carbon dioxide-rich atmosphere. It's a fascinating example of how we can use the resources available to us in space to support human exploration and perhaps one day colonization. With the problem and resources understood, let's delve into the solution. How do we turn this carbon dioxide into breathable oxygen? We're going to break it down quite literally using a process called electrolysis. This isn't your ordinary science experiment, it's a sophisticated dance of atoms and molecules that could spell the difference between survival and suffocation on the red planet. So what is electrolysis? In simplest terms, it's a method of using electric current to cause a chemical reaction. In this case, we're looking to split carbon dioxide, which is abundant in Mars's atmosphere, into oxygen and carbon monoxide. This is achieved by passing an electric current through the carbon dioxide, which encourages the molecules to split apart and reassemble into these new formations. Now you might be wondering how we're testing this out on Mars. Enter the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE for short. It's a little box about the size of a car battery, snugly fitted into the belly of NASA's Perseverance rover. MOXIE has a big job. It's tasked with demonstrating that this process of electrolysis can work in the harsh Martian environment. Here's how it works. MOXIE sucks in the Martian air, which is about 95% carbon dioxide, and compresses it. It then heats this compressed air to around 800 degrees Celsius. This high temperature is crucial as it allows the carbon dioxide to react with the electric current more efficiently. The current is then passed through the heated, compressed air, which causes the carbon dioxide molecules to split into oxygen and carbon monoxide. The oxygen is stored and the carbon monoxide, which isn't useful for our purposes, is released back into the Martian atmosphere. MOXIE's job doesn't stop there, though. It also has to monitor the oxygen it produces for purity. We can't have astronauts breathing in substandard oxygen after all. But don't worry, MOXIE has got it covered. It uses sensors to measure the oxygen and ensure it's up to the mark. This process may sound straightforward, but keep in mind that we're operating in an environment where temperatures can plummet to -80 degrees Celsius at night, dust storms can last for months, and the air pressure is less than 1% of Earth's. These are not ideal conditions for delicate chemical reactions, and voila, we have oxygen. But the process is not as simple as it sounds, and there are many challenges. From maintaining the precise conditions necessary for the reaction, to scaling up the process to produce enough oxygen for a crew of astronauts, there's a lot of work to be done. But with each successful test, we're inching closer to the goal of making Mars a place where humans can not only visit but live and breathe. Creating oxygen on Mars is not a walk in the park. It comes with its fair share of challenges. The first of these is the colossal energy requirement. The process of converting carbon dioxide into oxygen is energy intensive. The machinery needed to do this on a large scale would require a power source far beyond any conventional means we currently have deployed in space. Then there's the harsh Martian environment to consider. Mars is not only colder than Earth, but it's also bombarded with solar radiation due to its thin atmosphere. This radiation could damage the necessary machinery over time, necessitating regular maintenance and repair. And let's not forget the Martian dust storms, which could potentially bury and damage equipment. Furthermore, the process for making oxygen itself still requires more testing and refinement. The Perseverance rover's MOXIE experiment is just the first step. It's a proof of concept showing that it's possible to make oxygen. But to sustain a human mission or even a permanent human settlement, we'll need to scale up this process significantly. That's a whole different ballgame. But let's not get bogged down by the challenges. Instead, let's look at the future prospects of this technology. If we can overcome these difficulties, the ability to produce oxygen on Mars could revolutionize space travel. It would mean that astronauts wouldn't need to carry vast amounts of oxygen with them, reducing the cost and complexity of missions. It could even pave the way for long-term human settlements on Mars. And the implications extend beyond Mars. If we can make oxygen on Mars, we could potentially do it on other planets too. This technology could open up the entire solar system for human exploration, and that's an exciting prospect. Despite the challenges, the prospect of creating oxygen on Mars is a giant leap towards making Mars a second home for humanity. We've embarked on a journey today, from understanding the need for oxygen on Mars to the process of creating it. We've delved deep into the Martian atmosphere, uncovering its complexities and exploring the innovative methods we can use to generate breathable air. We've grappled with the concept of taking Earth's most abundant life-sustaining element and creating it in an environment where it's virtually non-existent. We've seen how, by leveraging advanced technologies and a touch of human ingenuity, we can convert the carbon dioxide-rich Martian air into oxygen. We've also discussed the challenges we face, from the harsh Martian environment to the logistical hurdles of transporting and maintaining the necessary equipment, yet we remain hopeful. The future of space exploration hinges on our ability to overcome these challenges and create a sustainable environment for human life on Mars. This isn't just a scientific endeavor, it's a testament to human resilience, innovation, and our inherent desire to push boundaries. It's a glimpse into a future where the confines of Earth are no longer the limits of humanity. But here's a question for you. Do you think we will be able to create a breathable atmosphere on Mars in the future? Share your thoughts in the comments. And if you enjoyed this cosmic adventure, don't forget to like, share, and subscribe for more fascinating journeys into the universe.